I want to revisit what I did for the Unbuffer or Jack Orman's pickup simulator that I made in the previous video. The results, when I made it the first time, weren't spectacular. I really couldn't tell a difference from the input signal to the output if I had it active or if I had the circuit bypassed. I really couldn't tell a difference. So it made it difficult to tell when it was on, and there was just something that wasn't right. A viewer pointed out that I might have, even though I went through all the math, I might have chosen a bad transformer for this circuit. So I went back and did some review, and I found a couple of things. For one, the potentiometer that I used for this project the first time, there was an issue with it, and even though I could move the knob back and forth, the value only went down so far. It never went quite to zero, and it stayed at about 10K or so. So that is a huge issue, and it's no wonder that I wasn't able to hear it changing that much because the volume pot was malfunctioning. So I went back and I changed that pot out, and that made a huge difference. But I also made another change with the capacitor, and let me tell you why I did that. So in the original video, I went through, and the original part that was called out on the schematic was this 42TM019, and it gave me a resistance value and a Z value, or the impedance value, at 1 kilohertz. And so I had to go through some calculations to figure out what the inductance value was, 1.59. Now, the tester that I used to measure the transformer that I wound up using, it could tell me an internal resistance, just a DC resistance, and it could tell me an inductor value of 3.13. And so I had to go through these same calculations in reverse to figure out what the impedance was at 1 kilohertz. Okay, so those numbers were close. The inductance value was basically a factor of 2. The impedance was, again, another factor of 2. So what I did, I went into LTspice and I modeled the circuit for the pickup simulator. So there's my circuit. I have my inductor, I have my resistance or potentiometer, and I have a capacitor value. Now for the circuit, the way it was originally designed, copy these values here, I'm really not going to worry about the resistance value because this is a potentiometer. I can essentially change this anything from 0 up to 25K. So the original circuit called for a 1.59 Henry inductor and a 330 picofarad capacitor. What I wound up using was a 3.13 Henry inductor, and the closest value that I had in my parts box was 300 picofarad. Pretty close. When I modeled this in LTspice, I came up with some pretty surprising results for the resonant frequency. Okay, so what's a resonant frequency? Anytime I have an RLC circuit like this, there is a frequency that the amount of attenuation that I get from the inductor and the capacitor, there's a point where it seems to resonate, where more of the signal tends to get through. Now, to find out what the resonant frequency is, just going through the math, and it does agree with what came out in LTspice, my resonant frequency is 1 divided by 2 pi square root of LC. So what I can do is I can take these LC values, multiply this through, and I can get the resonant frequency. So for the as designed case, using the original 1.59 and 330 picofarad, the resonant frequency should be about 6.3 kilohertz. Going through my calculations again, the resonant frequency for the Unbuffer, the way that I made it, the resonant frequency came out to be only about 5 kilohertz. Still well within the range of human hearing, but appreciably less than the frequency as designed. Now, there is a way that I can modify this circuit using the parts that I did use, that I can shift that frequency down. I'm keeping the same inductor. I'm keeping the same resistance. The only thing left I can change is that capacitor. So it's pretty easy to figure out what I need to change. If I want the resonant frequency to stay the same, I want the frequency as designed to be equal to the frequency that I built. All right, so if I go through this, essentially what I wind up getting is the LC value. That product has to be the same for the design and for the as-built. So plugging in these numbers, 1.59 henries, 330 picofarad, and 3.13 henries, the capacitor that should be in the unbuffer that I make comes out, it should be about 168 picofarad. Now, that's about a factor of 2, and that makes sense. Since my inductance values are off by like a factor of 2, it makes sense that the capacitance should be about a factor of 0.5, which is about what that is. So I dug through my junk box where I've got all of these old capacitors, and I wound up finding one that measured about 160 picofarad. That was pretty close. And so there's the new capacitor that I put in. It winds up making an appreciable difference in the sound that the circuit has. Now I can sweep through the potentiometer, which has also been replaced, and I can hear the difference in the sound. Also, to make my life easier, I added an LED that I also got from this box of junk parts. This is a 1960s LED even. And so now I can tell the circuit is bypassed or the circuit is on. So that makes my life a whole lot easier. All right, so here I am back over at the pedal board. I've got the Unbuffer in here, and I've got my West Coast fuzz, which is just there to be in effect. All right, so with the Unbuffer bypassed, the LED goes out. So I know that I'm bypassed. I can turn the Unbuffer on. And I can absolutely hear a difference in the way the volume comes out through here. Try it on the tap mode. Success. Now I'm going to focus on the other end of this equation. This is not the right fuzz to use with an unbuffer. That same viewer, Mr. Ampy Amp, said, I need to try this with a fuzz face. So that's what I'm going to do now. I don't have a fuzz face, so I'm going to have to build one.